Prezi presentation is about segment and angle addition. As you can see on segment addition, we have a rule that we are combining one segment with another segment by a common point. So this is telling you that we are connecting segment PQ at Q with segment QR to make a total length of that segment PR. So as you can see in the green, PQ is a distance plus from Q to R is another distance to equal the total distance PR. Let's just say that you're running and you start at P, you go to Q, you take a rest, and then at Q, you continue on to R for a total distance of PR. And so when we take a look at this line with collinear points A, B, and C, with B between A and C, the red segment identifies the length of segment AB, plus the blue segment would be then BC. And so then the total segment from A to C then would be AB plus BC. Notice B is what's in common. It's between A and C. Should equal the total length of this segment, AC. So we are combining two segments to make a longer segment by angle addition. In the next slide, we can see that we are going to do a practice problem. First off, there is a sketch provided. If there is no sketch provided, you need to draw a picture with some point between the two endpoints. The next step is to identify the substitution for algebra into the picture. So JT is 3x plus 5. Put that over JT. It says that CT is a total of 69 units. We take our marker and mark it from C to T, and that's 69 units. And then from C to J, it is 4x plus 8. So we take the algebraic expressions and place it into our diagram. Next is to write a segment addition postulate, to write that. And so we do take CJ plus JT should equal CT. Notice that J is between C and T, and that's the connector between adding the two segments together. Then we draw our arrows, and we will substitute into CJ, JT, and CT from the picture or from the key legend. CJ is 4x plus 8 plus JT is 3x plus 5 should equal CT, telling us that that is 69. Now we're going to combine like terms on the left-hand side to get 7x plus 13 should equal 69. We're going to subtract 13 on both sides to get 7x equals 69. And we're going to divide by 7 to get x equals 8. Now I have to go back up and replace JT with 8. And so 3 times 8 plus 5 should give me 29 for JT. So I should have said that from the beginning. Find JT. And so that means when we write it like that, find the length of JT, we put our answer for our variable back into JT, and it's 3 times 8, which is 24, plus 5 is 29. We can find CJ one way is by taking 69 minus 29, and that gives us 40. And so we can find the other length just by subtracting off one segment from the total segment. All right, our next slide, what we're going to take a look at is I'm going to create a legend. And I'm going to say that AB equals 30 and BD equals 22. And I'm also going to say that BC equals the same thing as CD. So the picture is provided for you. We can see that B and C are between the endpoints A and D on this segment. And we can go ahead with AB being 30 and place it onto our diagram. We can say that BD is 22. So we connect B to D and we put 22. And we have BC equaling CD, so we'll put a tick mark on segment BC and a tick mark on segment CD. And so the next part we'll have to ask you is on A question, how long is AB? And B, how long is AC? In order to do this problem, we have to, again, go back to the picture and look what they're asking for us is AB. And I made a mistake here that it should be AD. So I'm going to go back up to here and say AD is 30, my mistake. And then I better take this off of my picture here and put that A to D. Again, all the way from here is going to be 30. Now they're asking me what is AB, and I'll draw that in green. And I can see that that should tell me that is 30 minus 22, or 8. I do know from B to D it's 22. I know the total from A to D is 30. The next one is to find how long AC is. These tick marks mean that they are the same length, BC and CD. Since the total segment BD is 22, C must be the midpoint. And so each of those then must be 11 and 11. And now they're asking me for AC. So AC is equal to segment AB plus BC. We came up with part A as AB being 8 plus BC we just came up with 11. So that answer there should be 19. Going on to the next slide. I'm getting used to these smart boards. You're erasing it. We are now looking at angle addition. And the parts of an angle, again, we have rays being the two sides, the vertex being where they connect the two rays. And this is considered in between the two sides are interior points, and anything on the outside of this angle is considered exterior points. And we also can be on the angle, which would mean we were either on the side. So we're either in,
Alexander Mead, please
out,
Meeting Center immediately.
or we can be
Alexander
on
Mead,
the angle.
please report to the
Three
meeting
different
center.
looks of that. Here we're looking at angle addition. We are looking at putting two angles that share a common side, and that common side, I can show you, is AC. And so since this angle BAC is arced in blue, I'll call that a slice of blueberry pie. And since angle CAD is marked in red, I will mark that, call that cherry pie. And so when I put the blueberry slice of pie next to my cherry piece of pie, I get a graded piece of pie, and that big piece of pie would be the green arc, angle BAD. So angle addition. You can think of slices of pizza putting together to make a great big slice of pizza, or you can take a look at it as look like little slices of pie. The next slide shows us the marking here. And as I said in class, this angle 37 goes with the arc, and I put an arrow there from side to side. So what is the measure of angle ABC? This is not drawn to scale. 37 degrees is next to this entire arc. So we must take half of it. And if we take half of 37 degrees, we get 18.5 degrees. Again, this angle is not drawn to scale, but it said this is 37 degrees. It goes with this arc, and therefore, since 37 goes with this arc, we would have to take half of this. Continuing on to the next slide. Again, it shows you the sector blueberry pie is 40 degrees. The slice of cherry pie is 83 degrees. We put it together and we get a great big piece of pie to be 123 degrees. We are looking here at, let's see if I can move this. There we go. If B lies in the interior of angle AXD, then angle AXD plus the measure BXD equals angle AXD. So it's just telling you that we're looking at AXB plus the measure of angle BXD to make the great big angle AXD, angle addition. Here we have a linear pair. We can call the first one here angle AXB, and then the adjacent angle to that is angle BXD. For the great big angle, as we can see it, is the straight angle, angle AXD. So we really could call this the measure of angle AXD, which happens to be a straight angle of 180 degrees. Now we come to the distance formula. And the distance formula is important when we graph our segments on a coordinate plane. So we have ordered pairs. As you learned in algebra, we call the first ordered pair with the sub 1s, x sub 1, y sub 1. The other endpoint, we will use the sub 2s, x sub 2, y sub 2. And the distance formula is the square root of, that's what you're going to do very last. You're going to take the difference of the x's and square it, plus the difference of the y's and square it. So we're going to honor, please excuse my dear Aunt Sally, do inside parentheses first, do inside parentheses first, then we go back and square that number, we go back and square that number, and because we're squaring that, we'll always be adding two positive answers. And so then we do the addition, and then after we do addition, we'll take the square root last. Another idea, too, for distance formula is to form a right triangle. We'll talk about that. You can form a right triangle, and you say a squared plus b squared equals c squared. So c would be equivalent to this distance formula. Next slide. They do a problem. They said, let our first coordinate be negative 3, 4, and our second coordinate to be 5, 2. And so if you were to graph that, I would off to the side, if you wanted to graph that on an XY, just to get a visual of it, you could have plotted negative 3, 4 somewhere here. And then you can plot 5, 2 somewhere here. And when you connect those two, there is our segment right there. Notice that we get the square root of 68, and when we simplify that, we get 2 square roots of 17. If I made a right triangle and I wanted to use the Pythagorean theorem, then I would form a right triangle. I can see here that the rise is 4 minus 2. So I went up 2, that's my rise. And my run went from negative 3 to positive 5. And so my run then would be 8. And if I'm going to use the Pythagorean theorem, then I can say this side is A, this side is B, and the hypotenuse is C. And so we apply the Pythagorean theorem that c squared equals a squared plus b squared. We substitute in for A. A is 2 squared plus B. We substitute 8 in as squared. Here we get 4 plus 64. So C squared equals 68. Then we have to take the square root of that. When we take the square root of that, that brings us back to saying C equals the square root of 68, or the square roots of 4 times the square roots of 17. Square root of 4 is perfect, so I can call it 2 square roots of 17. So I've shown you two ways to find the length of a segment. One, applying directly the distance formula, and secondly, creating a right triangle and using C squared equals A squared plus B squared. Next slide. The next slide is showing you videos. These videos will review exactly what I have just discussed and what we've discussed in class over our sections of segment bisectors, angle bisectors, and applying the distance formula. So you have your choice here to choose whatever video that you'd like to look at. You can look at both of them if you feel that you need additional help. I hope this helped on this Prezi presentation.